Hey guys, welcome to the channel. So if you guys have been watching the channel recently, I just uploaded a TIG welding aluminum video in which I use this piece of metal here. And recently I came across this. It says E4043. So this here is actually an aluminum stick rod or an aluminum stick electrode. And I thought, you know what, it might be fun just to see how this works and just kind of show you guys. So I know basically nothing about stick welding aluminum. I've never done it before. I'm just going to take what knowledge I have from stick welding steel and see how much of it applies here. So join me for this adventure, won't you? And let's see what happens when you try to stick weld aluminum. Okay, so here we are at the Everlast. I got my leads in. Now, see if I can read that. That says DC clamp positive, and that is what my stick electrode holder is hooked into. So, I'm going to be running this at DC positive. If you guys have seen the aluminum TIG welding video, I kind of go over how some of the different polarities work on aluminum. TIG welding aluminum is done on AC, alternating current, and part of the AC current is that positive polarity, which removes the oxide layer from aluminum. So, when I do this, I'm hoping that that positive polarity will just keep the oxide layer clear on the stick and that the flux can do all the rest. So, let me go ahead and turn this on. Everlast, and it lights up. So, I'm in TIG, steel, and stainless. I need to be on stick. I should be able to just stick. There we go. Alright. I think 159 is a little high on the amperage, so it's an 1/8 inch rod, but it's aluminum. And we're in this adventure together. So I'm going to start at 100. I'm going to try that, whatever these settings are, and we'll see what happens, I guess. Be right back. Let me go throw on my safety gear and get the camera on the tripod, and we'll see what happens. Alright, we'll see what happens. Ah, that was cool. Here we go. Come on, ground. I don't want to get any ground right now. I don't see if I will. So I was sitting there trying to get an arc and couldn't get it to arc out for me. I got one little spark and the edge. See if I can get this in here and focus. I'm on camera. Anyway, the strike point there immediately covered with flux from almost no arc at all. So, something to remember when you do this, you're going to crucible really bad. So I'm going to see if I can chip this off, and then we'll give it another try. Alright, take two. Let's see if I can get this. Oh, this thing is butter. Yeah, I'm putting some weight down on the thing to see if I can get it to ground better. That's a weird flux, by the way. try turning down the amperage. Alright, we've gone from 100 amps to 80 amps. Let's see what happens. Okay, that is weird. Okay, I can say with certainty that is the weirdest stick welding experience I've ever had. It burns insanely fast, so maybe I just got a thin rod, maybe I need to turn down my volt amperage a little bit more, but look at that weird flux. Look at it. That is so wonky. That is so wonky. Okay. So on the machine here, I dropped down to 80 and made a couple other adjustments. I might even drop this down to like 65. I'm going to go ahead and chip that flux and see what it looks like. I'm not expecting it to be pretty, but we'll see what it looks like. Well, I did tell you guys not to expect anything great, and yeah, it's not great. There is like no penetration in there. I just melted rod and didn't melt any of the base metal. So, that puts me in a strange position. Again, this is my first time ever doing it. I am doing this for the first time. This is the first time I've ever even put an aluminum stick electrode in the holder. So this is going to be a little weird. Obviously I don't need less amperage, so let's go ahead and turn the machine back on. So if we go with the rule of thumb method, actually, you know what, that's a terrible idea. But for those of you who don't know, the rule of thumb method is 1 amp per every 1,000th inch of thickness that you're welding. So a 1/8 inch thickness in thousandths is 0.125. So if you're welding 1/8 inch, you're supposed to use 125 amps. Ironically, this is the amperage that they tell you to run your stick rods when you're in school, because most of the school stick rods are 1/8 inch. So that's where they get that number from. I'm going to try something a little different. I think I covered this in my aluminum TIG welding video, but I'll cover it here again. Aluminum is a heat sink metal, so it moves heat out of itself really, really fast, and that's kind of what looks like what's going on. And for how fast that stuff was burning off, I'm going to try 70 amps, and what I'm going to do, come over yonder, grab this. Don't mind the noises in the background. Okay, so this here is a MAP torch. It uses MAP gas, and what I'm going to do is I'm going to take it and preheat that metal. Now, Ideally, the way to do this is with an acetylene torch, and make sure you know your safety on acetylene torches. But what you would do is you would turn on the acetylene gas, only the acetylene, light it, and then run your lit acetylene over the aluminum, and that will soot it. And then you crank up the oxygen to a neutral flame, and then you would run the neutral flame over your sooted aluminum until the soot disappears. And that is about 400 degrees on your aluminum, which is about where you want it for preheating aluminum. I'm not quite going to do that. What I'm going to do is I'm going to heat it up, and there should be some condensation on this metal. I'm going to heat it up until the condensation doesn't stick anymore. And by soot, I mean that kind of stuff. So this is an old little tester piece that I was messing around with when I was trying to get a MIG aluminum gun to set up. And I'm running into a lot of the same problem here as I am with the stick, and a large part of that is because it's not preheated. So I'm going to try and do some preheating and see if that works. Be right back. Alright, here we go. You'll notice off to the left there that I decided to add a little clamp. It felt like I was having a hard time getting a ground on this, so that's what that clamp's for, is just to help keep everything grounded. So, MAP gas. This thing has a nice little belt holder to keep everything out of the way. Let's open that up. All my gloves and safety glasses. Remember your safety equipment, guys. Gloves and safety glasses and all that other fun stuff. So, okay. I might be out of MAP gas. Let's find out. Yeah, it sounds a little empty. I might be out of MAP. Poof. 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 Hey! I don't know if you guys can see the condensation. It's not exactly like I got a great flame going here either. Hey guys, this is what happens when you start running out of gas. This is not supposed to look like that. Well, so much for that idea. Well, since we're out of MAP gas and I can't do a proper preheat, we'll try the rule of thumb trick at 125 amps and see how it goes. I don't know. You know what? I'm going to try some arc force too. So arc force is basically kind of a voltage balance. So I might play around with that and maybe find something that works. We'll see. Anyway. Alright, let's give that a try. See what happens. Here we go. This stuff is such a weird flux. Again, it burns really, really fast. It is weird to weld with. I will say that right now. Throw a glove on here. Alright, safety glasses on. Let's see what's under this. If it's any better or not. There's the crater. Oh, it chips so weird too. Oh, it's weird. It's so weird. The steel man in me is very weirded out right now. So weird. hopefully I didn't weld my little clamp in on there. Well, that looks more like it, to be honest, apart from, you know, the giant crater on there. Alright, I'm going to turn you guys off for a little bit while I finish cleaning this up, so you don't have to listen to bang, bang, bang all the time. Well, we got something that resembles a weld. You know, obviously it's a stick, not a TIG, so it's not as clean as something else, but, you know, my toes are fused in. It's a little built up, so I was already moving pretty fast. I probably need to move just a little bit faster on it, but yeah, and you can see the big crater there. So any of you guys who have seen my stick welding series on steel, when I'm talking about craters, that's what I'm talking about. And so, you know, if this was something that I was stuck doing out in the field or something, I'd come back and I'd fill in that crater after I cleaned it up. But hey, that's aluminum stick. Really weird. You have to run really fast with it, and I mean really fast. It's scary. But if you're stuck and this is the only option that you have left to you, you know what? You can do it. You know, don't let anyone tell you you can't do it. It took me like 2 runs to kind of figure out what I was doing. You'll definitely need to practice it, and I'm sure if I sat down and practiced it, I'd get a lot better than this. Burns up the stick really quick. Keep that in mind. It is not like stick welding steel. It is hot and fast, and you got to get your hands in gear. Keep in mind, so earlier I said that aluminum is a heat sink metal, so it dissipates heat fast. So if this material was thicker or just overall bigger, had more surface area on it, I probably wouldn't have gotten that weld. I probably would have had to preheat it. I think I got a little bit lucky, and now I know that my torch needs some gas, but there you go. So, it can be done. Don't let anyone tell you it can't. You know, there's going to be a lot of guys out there who say, oh, don't even bother stick welding aluminum, just TIG it. Well, TIG's expensive. You got a bottle, you got the machine, you got the torch, you got the tungsten, a whole bunch of other stuff. So if you need to, you can stick it. It's going to take a lot of practice. You're going to have to try and figure out what you're doing, but guess what? You can do it. If I can do it, you can do it. Just be prepared to use a lot of rods, because those 2 little beads pretty much ate up 3/4 of the rod, if not maybe a little bit more. Anyway, there you go. There's some stick welding. Remember, run fast, run it hot if you need. Apparently the rule of thumb trick ended up working out. And that's all I got for you today, guys. Hope you guys found something interesting. Hope you guys learned something. And we'll see you guys in the next video.